It is a Tuesday evening in July, and the air is thick, heavy, and hot. Inside millions of homes, the same quiet reflex occurs. Fingers press buttons, and air conditioners hum to life. For a few hours, everything is perfect. The modern miracle of climate control keeps the summer at bay. But then, without warning, the hum stops. The television screen goes black. The lights flicker and die. You look out the window. The entire neighborhood is dark. It is a blackout. When this happens, our immediate assumption is simple. We ran out of electricity. We picture a massive reservoir of power that was drained dry because too many people plugged in too many things. But that assumption is wrong. The grid did not fail because we ran out of energy. Something far more interesting and far more invisible happened beneath our feet. To understand what actually broke, we have to look at the silent gamble that keeps our civilization running. Because the power grid was never designed to give everyone power at the same time. To build a grid that could handle every single appliance running simultaneously would be a physical and economic impossibility. Instead, our world relies on a beautiful, hidden pattern of human behavior. That pattern is diversity, and it is the only reason the lights stay on. Think about a typical day. In the morning, you wake up, brew coffee, and toast some bread. But your neighbor isn't doing that. Maybe they work the night shift and are fast asleep. This constant, natural shifting of activity is what engineers call the diversity of demand. Most days, this statistical assumption works beautifully. We naturally stay out of each other's way. But what happens when a force of nature strips away those differences? This is what a severe heat wave actually does. It is not just hot, it is a giant invisible synchronizer. When the temperature crosses a critical threshold, human behavior stops being diverse. The office buildings don't shut down their cooling systems when workers leave. They have to keep massive servers from melting. The factories can't turn off their ventilation. The supermarkets must run their massive freezers at maximum capacity. And at home, nobody is waiting until midnight to turn on the air conditioner. Suddenly, millions of independent decisions collapse into one single, synchronized demand. Everyone, everywhere, wants the exact same thing, at the exact same intensity, at the exact same second. The invisible buffer of time that engineers use to balance the grid completely vanishes. To see what this actually looks like, imagine a neighborhood of 1,000 homes. Usually, their power usage is a gentle, staggered heartbeat. But as the clock strikes 6 p.m. on the hottest day of the year, an invisible wave passes over them. Instantly, every single house flashes a violent warning red. No stagger, no turns, one massive vertical wall of demand. Imagine if every single car in a massive metropolis tried to slide down the exact same highway exit at the exact same minute. Or if every commercial airliner in the sky tried to touch down on a single runway at the exact same second. Those systems wouldn't fail because they were poorly built. They would fail because they were never designed for perfect synchronization. This is the synchronized demand spike. And it is at this exact moment that a silent drama begins inside the control room. Inside, operators are not looking at power lines or light bulbs. They are watching a single, delicate metric, frequency. To everyone else, nothing has changed. But to the engineers, this number is the pulse of the continent. To survive, the grid must hum in absolute harmony. The generators across the entire landmass must spin at the exact same rhythm. But as millions of AC units turn on at once, the massive turbines in our power plants feel a sudden physical resistance. They begin to struggle. The synchronized load acts like a giant weight, slowing down the spin. On the monitors, that quiet, steady frequency number begins to slip downward, away from its strict safety limits. Operators move fast. They fire up emergency reserve generators. Expensive, heavy jet engines kept on standby. They try to buy electricity from neighboring regions, desperate to inject balance back into the slowing system. But during a widespread heat wave, those neighbors are fighting the exact same battle. There is no help coming. And that is when the physical trap closes. Because the heat isn't just driving up demand, it is choking the machinery. The massive copper wires carrying this emergency power get incredibly hot, but they can't dump that heat into the boiling air. The metal physically expands. The heavy lines sag, dropping dangerously close to trees and ground. To prevent a catastrophic ground fire, operators are forced to do the unthinkable. They choke the capacity of the wires. Meanwhile, the physical plants producing the electricity are losing efficiency because the rivers they use for cooling are running warm. Everything is moving in the wrong direction. The demand curve is a vertical wall, but the physical system is shrinking. Back in the control room, the frequency line drops further, approaching the final safety threshold. If it falls past this limit, the giant turbines will automatically shut themselves off to prevent physical destruction. If they shut down, the entire regional grid collapses in a matter of seconds, a cascading blackout that could take weeks to fix. To save the machine, the operators pull the emergency lever. They intentionally cut off power to your neighborhood. This is the rolling blackout, a controlled, calculated sacrifice of the few to keep the system alive for the many. It is a stark reminder of our vulnerability. But humanity is not simply waiting for the next system failure. We are currently engaged in one of the greatest engineering shifts in human history. For over a century, the philosophy of the grid was simple: predict human demand and burn whatever was necessary to meet it. But in a world of synchronized extremes, we can no longer build enough power plants to keep up with the peaks. So we are redesigning the relationship between the grid and civilization itself. We are moving from managing supply to managing human behavior. Instead of building more fossil-fueled turbines, we are installing massive battery arrays that act as physical shock absorbers. They absorb excess power during the quiet hours of the day and release it instantly when the synchronization begins. More importantly, we are teaching the grid to talk back to our appliances. Through smart grids, instead of shutting down a whole neighborhood, the grid can quietly adjust millions of thermostats by just 1 degree. It can pause smart water heaters or delay electric car charging by mere minutes, distributing the load. By doing this, we use software to artificially recreate the diversity of demand that the heat wave took away. We are also turning millions of homes from passive consumers into active participants. Through virtual power plants, the battery in your garage and the solar panels on your roof become a distributed shield. When the grid starts to panic, it doesn't fire up a coal plant. It gently draws a fraction of energy from millions of homes. It is a profound shift. We are no longer trying to force the Earth to bend to our static infrastructure. We are building a system that is as dynamic and adaptive as the weather itself. But as we build these smarter networks, we are forced to look at our world through a different lens. The power grid isn't fragile because it's weak. It is fragile because it quietly assumes we will never all need the exact same thing at the exact same time. Our physical infrastructure, our technology, and the systems we rely on are sized only for our differences. We often think civilization is held together by steel, concrete, and technology. But every summer heat wave reminds us that something even more delicate holds it together. It is built on a statistical miracle: the simple, beautiful fact of billions of people accidentally taking turns. And once we stop taking turns, even our most powerful creations begin to bend under the weight of ourselves.